Hello everyone, this is Dr. Fan. In the previous video, we discussed how a football player can throw the ball to the longest range. And that also applies to a soccer player, to a tennis player. But in reality, hitting the longest range may not be as important as hitting a certain target. Let's see, a football player, if they want to score the goal, they want to kick the ball into the goal. And that basically means hitting a target is more important than throw the ball to the longest range. And today, let's use the knowledge from 2D kinematics to work on a very good practice problem. Alright, let's get into it. So let's say the question is set up like this. So a player kicked the ball at an initial speed of 20 meters with a launch angle of 30 degrees above the horizontal. And the player is facing the goal is 21 meters away from the goal, and the goal is 2.5 meters high. Can the player score the goal with this velocity and with this launch angle? This is a very interesting question. So how can we prove or disapprove if the player can score the goal? We know if the player wants to score the goal, the ball needs to have a horizontal displacement of 21 meters. And the ball also needs to have a vertical displacement which is larger than 0 but smaller than 2.5 meters. So in other words, the ball needs to satisfy both the horizontal displacement and the vertical displacement. So how do we actually solve this problem? We know the initial velocity is 20 meters per second, and we also know the launching angle, which is 30 degrees. We know we can decompose this velocity, the initial velocity, 20 meters per second, to its horizontal component, v0x, and its vertical component, v0y. We have done this before. We know the horizontal component, v0x, equals to v0 times cosine theta, and we know the vertical velocity, v0y, equals to v0 times sine theta. So if I substitute the initial velocity and the launching angle into these equations, I can find out the initial horizontal velocity, which is 17.3 meters per second. I can also find out the initial vertical velocity, which is 10 meters per second. Alright, now we know the initial horizontal velocity and the initial vertical velocity. So how do we actually prove if the player can score the goal? So the key to solve this question is to assume the player can score the goal. Then we know the ball needs to satisfy this horizontal displacement, but also the vertical displacement. The horizontal motion is much easier because along the horizontal direction it's constant velocity. In other words, we know delta x equals to v0x times t. And because we know the initial horizontal velocity and we know the horizontal displacement, we can find out the time. So the time equals to delta x divided by v0x. And after calculation, we got 1.2 seconds. So in other words, we know if the ball travels from this launching point to the goal, which is 21 meter horizontal displacement, we know it takes 1.2 seconds. Then we just need to make sure if the vertical displacement is correct or not. And for the vertical displacement, we know the vertical velocity. We also know the vertical acceleration, which is minus g. So if I substitute all these values into the kinematic equation, my delta y equals to v0y t minus half gt squared. I know my initial vertical velocity, I know my time, and I know g. So if I substitute everything into this equation, I get 4.8 meters. So what does that mean? That means when the ball travels 21 meters horizontally, the ball has a vertical displacement of 4.8 meters. That means, if I'm using a different color, the ball overshoots. The ball at this horizontal displacement has a vertical displacement of 4.8. So the player cannot score the goal. He overshoots it. What if you get a vertical displacement that is smaller than 0? For example, what if delta y is smaller than 0? That means he undershoots it. That means the ball goes under the goal. That also means he cannot score. Alright, so under what velocity the player can actually score the goal? Let's look at a very similar question, but from a different perspective. So let's say we keep the same launching angle, 30 degrees, and we keep the same horizontal displacement, and we keep the same height of the goal. So the question asks, under what speed can the player score the goal? This question looks a bit tricky in the beginning, but if we think about it, we can look at the two extreme situations. So one extreme situation is the ball just hit the upper crossbar. Or another situation is the ball just hit right in front of the goal line. So any speed in between should be able to help the player to score the goal. In other words, we just need to look at these two extreme cases. Under this case, if the ball hits the upper crossbar, so the delta y equals the height, which is 2.5 meter. And under the second situation, if the ball hits right in front of the goal line, delta y is 0. And under both situations, the horizontal displacement does not change, which is 21 meter. Alright, so this question asks under what speed? So how do we actually find out the speed? So from this question, we know the launching angle, which is 30 degrees. So we know the launching angle, which is 30 degrees. We know the horizontal displacement, and we know the vertical displacement. So how do we actually find out the speed? Let's look at what we do know. We know along the horizontal direction, delta x equals to v0 cosine theta times t. We have showed this many times. And along the vertical direction, we have delta y equals to v0 sine theta times t minus half gt squared. So if you look at these two equations, you have two equations and you have two unknown. The first unknown is the time. The second unknown is the initial velocity. So if we get rid of t, we would only have one unknown, which is my initial velocity, and which is what the question asks. So from the first equation, we know t equals to delta x divided by v0 cosine theta. So let's say this is equation 3. So if I substitute equation 3 into equation 2, I can get one equation with only one unknown. So if we substitute equation 3 into equation 2, let's see what we will get. So my delta y would equals to v0 sine theta times t, and this is my t, which is delta x divided by v0 cosine theta, and then minus half g t squared. And what is my t? This is my t. So it's going to be delta x squared divided by v0 squared cosine theta squared. And if I simplify this a little bit, this and this can be simplified as delta x times tangent theta minus half g delta x squared divided by v0 squared cosine theta squared. So let's say this is my equation 4. And in this equation, let me use a different color. I know my vertical displacement, and I know my horizontal displacement. I also know my angle. So everything is known except the initial velocity. So if I substitute the value, I can find my initial velocity. So I have done the calculation. I know when delta y equals to 2.5 meter, my initial velocity should be 17.5 meter per second. And if my delta y equals to 0 meter, meaning the ball hits right at the goal line, my initial velocity should be 15.6 meter. That means as long as my initial velocity is larger than 15.6 and smaller than 17.5 meter per second, the player can score the goal. Based on this calculation, you can see that the suitable speed has a very small range. That means the player definitely needs a very good skill to score the goal from such a far distance. And this equation we derived here is very important because it basically includes all the important parameters in one equation. Hopefully, today's discussion will help you to solve the questions related to hitting a target in 2D kinematics. Thank you very much. I will see you next time.